Hey everybody, it's Mr. Sauce here. Hope you guys are doing all right. I just want to go over assignment number 3 that's going to talk about equivalent ratios. And these are just made up examples. They don't happen to be on assignment number 3, but what we can do is use the skill that we're going to be talking about in these 4 examples and apply it to that assignment here. So what we need to talk about is the word equivalent, right? And just realize that equivalent just means right equal to. And when we're working with ratios, right, our ratios, we have two numbers to our ratios, right? If we had 1 to 2, an equivalent ratio of 1 to 2 would be 5 to 10. All right, so 1/2 is equal to, it has the same value as the ratio 5 to 10, right? 5 is half of 10, 1 is half of 2, right? So although they're different numbers, they have the same value. Okay. If I got one question out of 2 on a test correct, and another student got 5 questions on a different test out of 10, we'd have the same grade of 50%. Right? So it's the same value, just working with different numbers, and that's what the term equivalent just represents. So when we are working with these ratios, the one thing that matters the most is the order, right? And our ratios that we were just talking about, they all have 2 terms to them, right? We have let's change the color up, let's go red. We have our first terms, which are the first numbers in each ratio. And then we have our second terms, which are the second numbers in each ratio. And that exists on all of these problems and the ones that we are doing on assignment number 3 here. So let's just label all of the terms here so we can take a look, right? We have our first terms, which come first, and then our second terms. And then in our other ratio, we have our first terms and our second terms, right? So that's kind of the terminology that I'm going to be using as we go about some of these examples here. And the order matters, meaning our first terms have a relationship and our second terms have a relationship, right? And it's actually the same relationship. And we'll talk about that in just a second. But what also will help us out is if we have access to a multiplication chart. So I'm just going to refer to this on the screen as we do some of these problems together. But we are going to find success if sometimes we don't need to, right? Sometimes we have our good mental math facts, right? But other times it will help us and will give us some assistance in finding out what the relationship between the numbers are going to be. Okay, so for number 1, we have the ratio 5 to 10 is equal to some number, right? X just represents an unknown, okay, to 30. And what we need to do to start is we need to find out what the known values are. So when we're looking at this ratio, we don't know what X is. So that means that our first terms are considered unknown, right? We already know what 10 is, right? It's 10. And we know what 30 is. It's 30, right? We're not trying to find out what the second terms are. We need to find out what this specific first term is, right? So after we find out what the known values are, we want to find the relationship between those known values. And when we're working with relationships, right, it's either going to be multiplication or sometimes we can look at it as division, right? But we want to find the relationship between the knowns. Okay. So going over number 1 real quick, if we were to look at 10 and 30, right? To go from 10 to 30, there's some sort of rate or some sort of relationship that we have to do to the 10, which would be multiplication in this case, to get to a 30, right? And you're probably thinking right now that it would be multiplying by 3, and you'd be absolutely correct in that case. However, if we were looking at our multiplication chart, and let's just zoom in on it a little bit. We were looking at our multiplication chart. and we have the values 10 to 30. We want to find out, and this is if we didn't know what our rate was or our relationship was. We want to find in one of these rows, we want to find the values 10 and 30. Now I see 10 here and 30 as well here, but I also find in the tens column, right? If we start with 10, we have a 30 here as well. So if we start at 10, right, in order to get to 30, we must take a look here at the very top of this multiplication chart to find what we multiply by. And it would be by that 3 term, right? So it's going to be 10 times 3 would get you to 30 here. All right, so let's just erase this for the next problem. But that's how we're going to use our multiplication chart to help us out. All right, so we want to find where 10 and 30 are. Right, if we had 10 to get to 30, we go all the way up and it would be 3 times we're multiplying it by. All right, so going back to our problem here, we have our relationship of times 3 to go from 10 to 30. And what that does for us is we actually use the same exact rate or relationship to go and find out what this missing value would be. Right? So whatever 5 times 3, right, same rate, would complete this first ratio. So it would be 5 times 3. If we go 5 and then times 3 up there, we want to do like a battleship, right, where they meet, would be 15. And our value that's missing here would be 15, and then completing that would be 15 to 30. All right, and that's how we're going to be solving these problems here, everybody. All right, so let's just erase the multiplication chart. Let's kind of clean this up a little bit. I guess we can go on the bottom here. We don't have to clean it up. And let's try out number 2. All right, so in number 2, we have x to 18 is equivalent to or equal to 2 to 6. Now take a second and try to find out what the known values are in this relationship or in this ratio. So pause the video and see if we can find out the known values. And if you said that the 2's, right, the second terms, are the known values, you're absolutely correct. Okay, because we don't know, obviously, what this first term is, right? We know the 2, but we don't know what this x is, right? So that makes that an unknown, right? Unknown value this time. So if we take a look at our steps, right? Step number 1 was, what are the known values? They're the green ones, right? 18 and 6. We already know the values of that. Our second step would be to find the relationship between the known values. So if we went from 6, let's change that to green here. But if we went from 6 to 18, there's a multiplication that we're doing to 6 in order to get to 18. And if we take a look at our multiplication chart, go all the way up to the top, we'd find out that we multiply 6 by 3 to get to 18. So that would be our relationship here in problem number 2. Our third step is we have to apply that relationship, that same relationship. So that would be multiplying by 3. Oops, let me just spell that correct here. So that would be multiplying by 3 to the unknowns. And what we have to do now is find out what 2 times 3 would be, right? That same exact rate. So 2 times 3 would get us to, if we take 2 multiplied by 3, 2 and 3, they meet together at 6, right? So 2 times 3 would get you to 6, completing that first ratio. So our unknown value would be 6 in that problem. Okay, and that's all we're looking to do for these types of problems here. Number 3 is very similar, So we're going to do number 3. And then number 4 has one specific step that we have to look to do first before we solve. So number 3, take a second and see if we can find the known values. You can pause the video and see if you can do so. And if you found that our known values are again the second term, right, 4 and 24, we know both of those, then you're off to a good start with this one, right? And that means that, like yellow here, we'll go red. And that means that our first terms are our unknowns. We know what 3 is, but we don't know what x is. So our focus, everybody, should be on the second terms here in the ratio. So in order to go from 4 to 24, right, we need to find the relationship. Take a second and pause the video to see if you can find out what that relationship is to go from 4 to 24. And if you found that it was multiplying by 6, then you're absolutely correct. And lastly, right, in order to finish up and solve that missing value, we need to apply that same relationship of times 6 or multiplying by 6 to our first term here. So it would be 3 times 6, 3 and 6. They meet together at 0.18 on the multiplication chart. So our missing value in this case would be 18. And to complete the ratio, it would be 18 to 24. All right. So that's how we can use multiplication or division, right? If we went the other way, if we went reverse, it'd be divide by 6. It's 24 divided by 6 would be 4. But you can either use multiplication or division to find out what your missing values would be. Now our last problem here, we have to do something first to it. And what I mean by that is we have to simplify our first ratio before we begin. Because if we take a look at it, right, just clean up the box here. But if we take a look at our first ratio, our first terms are our known terms, right? We know 7, we know 10. And our unknown terms in this case would be 21 and x, right? We know what 21 is, but we don't know what x is. However, there's no number that we can multiply by 7 to get to 10, no whole number at least. And we want to find a whole number that we will be able to multiply, right? 7, we can go to 7, we can go to 14, but we can't go to 10, right? Somewhere in between there. So that means that we have to pick another strategy, and that strategy is to simplify our first ratio. And what we need to do is we need to find a value that can go into both 7 and 21 and divide it out. All right, so this is where our multiplication chart can come in handy again. So we need to find 7 and 21. And the way we do that is we look in each row. We look in each row here, and we see if we can find the number 7 and the number 21. And I always like to start, if it's a single digit number, right? If it says 7 and 21, I like to start with whatever that the smallest term is, right? The 7. And we can find that in the rows that 7 exists in, right here, in the 7 row, we can find 7 and 21. And 7 can go into 7. This is how we do this. We go look to the very top one time. And 7 can go into 21 3 times. So what this means is that this ratio, 7 to 21, is equivalent to the ratio 1 to 3. So backing up real quick, let's go back to this problem, and let's finish this one up here after we've just simplified. So like we just did, 7 can go into 7 one time. And let's just write that again here, 1. And then 7 can go into 21 3 times, right? So we want to, when we simplify, we want to divide by the same number into both of the ratio, both of the numbers in the ratio. So we just created a new ratio here of 1 to 3. And that still equals this original one, 10 to x. So just clarifying, right, we still know what the first terms are, right, 1 and 10, and we don't know, obviously, the x, and we don't know the 3. So we're going to have to focus in on what we do know. And to go from 1 to 10, right, if we go from 1, and let's clean up the multiplication chart here. But if we go from 1 to 10, pause the video and see if we can find the rate or how much we multiply by 1 to get to 10. And if you find the ones column, go all the way to 10, we multiply by 10, right? Anything times 1 is itself. So 10 times 1 would always be 10. 11 times 1 would always be 11, etc. So that means that we have to use that same rate, which is times 10, and apply it to that last term in the ratio. So it would be 3 times 10, and 3 times 10 meets up at 30. So completing this ratio here, we'd have 1 to 3 equals, or is equivalent to, 10 to 3 times 10, which would be 30. And 30 would be your missing value. Okay. This last one was exactly like number 2 and number 10 on assignment number 3. All right, so on numbers 2 and numbers 10, simplify those first. Simplify the ratio that we know first, and then you'll be able to solve it out. So I hope this video helps. Please reach out if you have any questions with this, and I will see you guys soon. Take care, everybody.